Okay, so today is March 25th. This is our online session, and we're going to go over a few problems, maybe a couple problems from each section. There are a couple people that are online, and they're going to type questions in the chat window or unmute if they'd like to ask a question. Otherwise, we'll go ahead and begin. So we finished up 5.4. That should be in your homework that's due this weekend. So we had done everything in class except for rationalizing the denominator. So let's just do a couple of those and make sure everybody has that. So if you want to rationalize a denominator that just has a single radical in the bottom, so let's say we've got like square root of 3 over square root of 5. To rationalize the denominator with just a single square root, you just need to multiply it by itself. So we know if we multiply square root of 5 times square root of 5, we just get regular 5. And in order to do that, we've got to do it on top and bottom, so that we're multiplying by 1 and we haven't changed anything. So on the top, we get square root of 3 times square root of 5 is square root of 15. And on the bottom, square root of 5 times square root of 5 is just regular whole number of 5. Okay, so if it's a single radical in the denominator, you just multiply it by itself. If it's not a single radical, let's say we got square root of 3 plus 1 and square root of 2 minus 1. So if we multiply by square root of 2, we're not going to get rid of the square root. So what we have to do is we have to multiply by the conjugate. So remember, the conjugate is where we have sum and difference. That was the last thing that we did together in class. So if this one's a difference, then the conjugate would be the sum. Okay, so we've got to do sum and difference, so we get the difference of two squares, and that'll get rid of the radical. So I multiply on top and bottom by the conjugate of the bottom, because remember, we're trying to get rid of the square root on the bottom. So on the top, we're going to FOIL. So we've got first and outer. So I'm going to have square root of 6. So square root of 3 times square root of 2 is square root of 6. Square root of 3 times 1 is square root of 3. 1 times square root of 2. And 1 times 1. So I get that on the top. On the bottom, when you multiply this out, it's sum and difference. So you can multiply it all out, but the two middle terms are going to cancel out every time. We've seen that a few times. So you can just do the first and the last, because the outer and the inner are going to cancel out. So you do square root of 2 times square root of 2 is just regular 2. Minus 1 times 1 is just 1. So we get square root of 6 plus square root of 3 plus square root of 2 plus 1 all over, and this is just going to be 1, and anything over 1 is just what you have. So we don't need to write this over 1, we can just leave it like this. And then you look to see if you can do anything else. None of these are going to simplify. We can only combine them if they're exactly the same. So I can't put together square root of 6 and square root of 3. They have to be exactly the same. I can't put together 3 and 2, and I can't put a whole number with the square root. So as far as addition and subtraction go, I can't do anything here, and that's my final answer. Okay, so if you have a single square root, you multiply by itself. If you have a complicated term like this, a binomial, then you multiply by sum or difference. Does anybody have any questions on rationalizing the denominator before we move on? Okay, looks like everybody's good. If you have a question, you can unmute or you can type it in the chat window. Either way is fine. Okay, moving on to 5.5. This is where we solved radical equations. So the key here is to get the radical by itself and then do the opposite. Okay, and in general, we solve equations by doing the opposite, right? So when you get the radical by itself, the opposite, in this case, the opposite of a square root is a square, the opposite of a cube root is a cube, so you use the opposite exponent this time to solve. So if we have something like x plus 2 equals 3, we already have the radical by itself, there's nothing else on that side of the equation, and we can do the opposite. We would square both sides. And when we do that, we've got to square the whole left-hand side and the whole right-hand side. And this on the left, the square and the square root will cancel because they're happening at the same time. So we would get x plus 2. And on the right, we've got 3 squared, which is 9. And now we're going to solve for x, so we do the opposite. Oops, that's a 2. And we get that x is equal to 7. Now, when you do these problems, you have to go back and check because you might have an answer that doesn't work in the original equation. So we have, if we plug 7 back in, we're going to do 7 plus 2 is 9, and the square root of 9 is 3, so that one does work. Okay, let's say we've got cube root of x plus 1 plus 2 equals, let's do 1. Okay, so our first step is to get the radical by itself, because if I want to do the opposite, which is cube, but if I try to cube right here, I'm going to have a mess because we can't distribute an exponent. So you can't cube term by term, you can't distribute an exponent, so we don't want to do it here because that's a mess. So I'm going to undo that. I need to get the radical by itself first, which means I need to move this 2 over. So I get cube root of x plus 1 is equal to -1. Now the radical is by itself, and now I can do the opposite. The opposite of a cube root is cube. So the cube and the cube root now can cancel because they happen at the same time. I get x plus 1 equals -1 cubed would be -1 times -1 times -1 is -1. So now I'm down to this, x plus 1 equals -1. I can subtract 1 from each side to get x by itself, and I get that x is -2. Now with cube roots, we don't have the problem of positive or negative, so the cube root should always check. You never need to throw out a solution for these. If it doesn't check, then you did something wrong. So just to check it real quick, we have the cube root of -2 plus 1 plus 2 equals 1. So this would be the cube root of -1. The cube root of -1 is -1. -1 plus 2 is equal to 1, and that does work out. Okay, so that's the basic idea there. Get the radical by itself and raise it to an exponent. Let's do one of the ones that's just a smidge more complicated and make sure that we're good with that. Let's do this one. Let's say we've got -x plus 14 equals 2. Okay, same idea on the first step. We need to get the radical by itself. So everything else has got to go to the other side. Now I've got square root of x plus 14 equals x plus 2. Got the radical by itself. I need to do the opposite, which is square. So I square the whole left, I square the whole right. On the left-hand side, the square and the square root cancel. On the right-hand side, I cannot distribute this exponent. I've got to FOIL it out. This is x plus 2 times x plus 2, and I need to FOIL this out. So we FOIL it all out. We're going to get x squared plus 2x plus 2x plus 4. So we get x plus 14 equals x squared plus 4x plus 4, and I'm now realizing I should have done these out of order like I told you guys to do them, because this is a quadratic equation. This is actually 6.1. That's why I told you guys to do 6.1 first, is because you have to have 6.1 in order to solve these. So assuming that you've covered all the material, we'll keep going from here. This is a quadratic. You know that because you see the x squared. So that means we're going to move everything to one side and factor. So let's move this stuff over. I'm going to have 0 equals x squared plus 3x minus 10. I'm going to come over here. Okay, so we've got 0 equals x squared plus 3x minus 10. Remember, to solve the quadratic, we want to factor. We want to have something times something equals 0, because the only way that you can get 0 is if you start with 0 when you multiply. So remember, that's the idea there. We'll do that in just a minute if you're having trouble with that. I need factors of 10 that give me 3, so 5 and 2 should do it. They multiply to be negative 10, they add to be positive 3, so I need plus 5 and minus 2. And we have something times something equals 0, so that means the solutions are x plus 5 must be 0, or x minus 2 must be 0. And we solve each of these little ones to get negative 5 and to get positive 2. Okay, so we get the radical by itself, we square both sides, and then we solve the quadratic equation by factoring. Now we have to go back to the beginning and check, especially when you get two solutions like this. A lot of times one of them will work and one of them will not work. So checking the negative 5 first. Okay, so I plug negative 5 back into my original equation, which is right here. That's going to give me positive 5 plus the square root of 9 equals 2. So I've got 5 plus 3 equals 2. Does that work? Double check your signs. Yeah, it should be 5 minus 3 equals 2, and this is definitely not a minus. Go back to the original equation and check. Those are not the same. That does not work, and I'm going to throw out that solution. Now let's check the other one. The other one better work. Negative 2 plus 2 plus 14 equals 2. So we've got negative 2 plus square root of 16. So negative 2 plus 4 equals 2, and that one does work, so we keep that solution. If you throw out both of them, that's a problem. You probably want to go back and check your work. One of them should check. Sometimes both of them check. I'm not intentionally going to give you ones where nothing checks. So you should have at least one solution when you finish these. Okay, any questions from 5.5? Any ones that you got stuck on in the homework or you want help with, or is everybody good? Okay, I don't see any questions for 5.5, so we will go on. Let's just go ahead and keep going in order since we already kind of skipped 6.1. Let's do 5.6. You know what? I'm going to go ahead and stop the video now.